Hello, good evening everyone. I hope you are doing well at home. I am Amit Sharma. Welcome you all on the platform of Medjeex, where you are mentored, nurtured and guided for your future. And what we have done till now, that is integration. In the integration chapter, we basically covered the geometrical interpretation, and specifically if I talk about the method of substitution. And that method of substitution is also followed by the method of all antiderivatives. What we say that, like, if a function's derivative is possible, that derivative is come out of that particular function which is which is called as antiderivative. Yes or no? I'll show you some briefing over there. After that I'll start today's lecture. So what will occur in today's lecture is what? Some special types of integration, and in that also we will take integration by parts and integration by partial fraction. So let's start with the today's lecture, where we'll study what I can brief you. First we will cover briefing. I'll let you know what we have studied till now. After that we'll start with some basic integrations, followed by integration by parts, and by partial fraction. And there will be some basic fundamental questions which will clear your concepts what we will taught over here. Is it clear? Some questions. Here you can see question practice session. Question practice session. Yes or no? Now let's start with the thing what we have discussed in the previous class. Not more than that, just simply the substitution method part 2 we covered in the last lecture. What is that? If I have to integrate such kind of integration like dx upon root over x square plus x a square, then I'll take the particular trigonometric identity which will simplify this. Then it can be only 1 plus tan square theta or 1 plus cot square theta. Am I right? Then I'll take a substitution of x is equal to a tan theta or x is equal to a cot theta, and we can simplify the integration, and we can get dx upon root over x square plus a square's integration into the format of natural log of x plus root over x square plus a square plus integral constant. Yes or no? And after that also we covered with a negative sign in the denominator which is coming in between x square minus x square and a square. Is it clear? For that I know what trigonometric identity I can utilize. For that I can utilize x is equal to a sec theta or a cosec theta. Taking the differentiation of this particular step, what I can do, I can mention such kind of steps and I can simplify this integration. Yes or no? After simplification we are getting natural log of x plus root over x square minus a square plus integrating constant, and this is the methodology, this is the derivation we are getting for such kind of integrations. After that we did dx upon x square minus a square's integration. In that also again I utilized the same identity of trigonometry, that is nothing but x, I am going to substitute x is equal to a sec theta so that it become sec square theta minus 1, or we can substitute x as cosec theta, then we can a cosec theta, we can get cosec square theta minus 1. Yes or no? We got simplification. I told you there are two methods. First one substitution, what is mentioned, and another one is that by simple algebraic manipulations, and that we have done over here. Yes or no? And we got the answer, and for that answer is nothing but 1 by 2a natural log of x minus mod of. What is the reason behind that we are keeping mod over there? For us, since it is an particular indefinite integration, and in that indefinite integration we don't know the value of x over here, and the difference can come out of negative also. To replace that negative situation we are substituting modulus over there, so that whatever the quantity coming over here becomes the positive one. Is it clear? Is this understood? Now this was general derivation of type what? Dx upon ax square plus bx plus c, and it is nothing but general quadratic expression. And for that quadratic expression, when we solved quadratic formula, we utilized completing the square method, and that using completing the square method we simplified such an expression. You can see by taking an a common, by putting the value 2 over here into the numerator and denominator, by subtracting and adding b square upon 4a square, and by keeping the thing in the mind that it becomes a complete square and it remains like to be root d square upon 2a, means root d upon 2a whole square. Yes or no? Now one thing is what, from here it can change to it can be done by two ways. What is that? It is possible that this quantity become negative, and it is possible that it quantity become negative. According to that, I am going to split the two ways. First one, if I am taking d as positive, if I am taking d is positive, then this will be the methodology. Just simply b square minus 4ac will be kept as d, and that root d upon 2a whole square is mentioned over here. And now you can solve it like previous one, this one. And if my d is negative, then what I can do, I can mention as minus. I am going to take minus, I am going to take common, then it will be plus, and this will become 4ac minus b square, and I am taking it as d1, and I have solved it using dx upon root x square plus a square. Is it clear? Is this understood? And that method was taught in the previous lecture, that if you are getting dx upon x square plus a square, then it will be simplified as 1 upon a tan inverse x upon a. Got that? And I have mentioned over here the same answer. This is the method I have simplified. Such simple expressions of integrations we have solved using some tricks, or what we can say is steps. What is the reason? If you will simply simplify it like reciprocating it and mentioning 1 by sine, multiplying sine square plus cos square and all, it won't result in a productive way. For that, just I multiplied cosec x minus cot x in the numerator denominator, and I have simplified it. Yes or no? This was the previous lecture we have done. The same thing we have did, and we have manipulated the answers. You must know one thing. In the case of indefinite integration, answer can vary, but all the answers can be related at the same platform by just simple manipulations. Just look at it here. One just cosec x, after integration of cosec x, I am getting log of natural log of cosec x minus cot x, and after simplifying into the sine and cos, I can get this one. I can get this one also, and all these results can be synchronized by manipulations only. Same for sec x, we did for cot x also using the substitution method. We utilized sin x, cot x ko just we have written cot x into the form of cos x upon sin x, and we have taken sin x as y, and just differentiating sin x with respect to x, we are getting this expression. In the substitution case, cos x upon sin x cos x dx is becoming dy, and dy upon y can be written as natural log of modulus y. Y is what? Y is simply just my sin x, just mentioned over here. In the similar way, this can be solved, means integration of tan x is nothing but either log of sec x or minus log cos x, which is written both. Both the answer can be utilized with simple manipulation. Now in the lecture, we also simplified some questions. This one, and this one. Yes or no? Now in the today lecture, what we will cover, we have mentioned over here already. Now start with the today's lecture. Such kind of integration, how you can do? sometimes the students puzzle with this thing. To resolve particular situation, I can say one thing. Just describe px plus q into the format of differential coefficient of ax square plus bx plus c. Yes or no? Then I'll write a times d by dx of ax square plus bx plus c plus b. Is it clear? Just we have to do what? Describe px plus q into the differential coefficient form of denominator and some constant quantity. Now students, what you can see, simply what? After differentiating, I can compare both of these, left hand side and right hand side. I can mention px plus q can be written as a times differentiation of this bracket will be written as 2ax plus b plus that constant term capital B. I hope this is very much understood to all the students, and it is very simple. Now px plus q, not so capital, just mention like this. Okay, now what I'll do, after multiplying this a into the bracket, I can just compare the results. Likewise this. Now you can continue in the same line also. Then it will be written as px plus q is equal to 2 times capital A small a x plus a capital AB plus capital B. Now simple comparison will be done. 2 times compare coefficients. After comparing coefficients and constant term, what I can see, this term is compared with this and this term is compared with this one. Not this one only, even this. Yes or no? What I can see, P will be written as 2 times capital A small a, and I need capital A only. Then I can say A can be written as small p upon 2a. Is it simple? Very simple, sir. Very simple. Now this one will be written as A times small b plus capital B can be written as Q. Now I want this B. I'll simplify by transposing this AB over there. Then it will be written as Q minus capital A small b. Then capital B will be written as Q. This is given. Capital A is written over there like P by 2a. You will write P small b upon 2a. And this you have to substitute over there so that I can do the integration of this one by using differential coefficient of the denominator. Yes or no? Now one thing, after writing, just mention it as I. Now I will be written as what? Capital A is what? Capital A is what? P by 2a. You have to mention over here. Just mention like first this expression, then we will write like this. Then we will write a times d by dx. I'll mention like this, a by d by dx, a into d by dx, differentiation of ax square plus bx plus c plus capital B whole divided by, dear students, I can write here ax square plus bx plus c. Now what I can write, I can mention differentiation of this one is already we have mentioned, that is 2ax plus b. But what is a? A is nothing but bp by 2a. Then you can mention I is equal to a as p by 2a. And what you can write? You can write 2ax plus b for as a differentiation. After differentiation, this will be 2ax plus b. Okay. And plus b. B will be what? B you can write as q minus p small b divided by 2a, and into the denominator I can mention ax square plus bx plus c. Now this is very simple to do integration. How, sir? How? Just let us know one more step and we can simplify the entire integration. Just to do that, I am just going to erase it. Don't worry. You will get this note over there in our application, that is Medjeex. You can see the entire notes till now what we have did. Now look at here, look at here, dear students, look at here. Now I'll simplify this step. For this step, I can mention I is equal to, just we have to write this one only. If I'll select it, it will shift like this. That is why I'm rewriting it. That is what I can mention this p by 2 as a constant outside the integration, just by the simple methodology of integration, and this will be 2ax plus b multiplied by dx whole divided by ax square plus bx plus c. Is this clear to all? Now plus that integrating element dx we have to have mentioned, and into the plus this entire constant term is kept outside the integration. This is nothing but q minus pb whole divided by 2a integrating with respect to dx, x elemental format of dx, that is ax square plus bx plus c into the denominator. Yes or no? Now all the dear students can see the result. This one we can integrate easily by substitution method. Now apply substitution. Substitution, what we can do? Just let ax square plus bx plus c as a t you can mention. Now after taking a differentiation on both sides, I can write 2ax plus b is equal to dt upon dx, since this parameter is different with this independent parameter x, correct? 2ax plus b into dx will be mentioned as dt, correct? Now in the next one, what I can see, this is a simple format of integration special format that we have studied in the last lecture, and we have discussed right now also, by taking an common, by mentioning all the quantities we have. The integration is depending upon the d discriminant. Yeah, just remember it. What are those? If from here we can divide it, if my d is less than 0 and greater than 0, in both the method discriminant will decide how we will integrate. Clear? Now the integration becomes what? Integration becomes of this particular, I can mention b upon 2a, not b, it's p upon 2a, 2ax dx becomes dt, okay, upon t. Now plus q minus pb upon, not whole upon, it's pb divided by 2a into the bracket, and we have to do the integration of this particular by what we have studied in the last lecture. I hope this is clear to all the students. Is this understood? Now see, this will become I is equal to p by 2a log of natural log of modulus t plus q minus pb whole divided by 2a. If my d is let d is less than 0 or greater than 0, whatever it is, let d is less than 0. If d is less than 0, I can say what? I am going to take a common, and this integration will become like this. This integration will become like this: x plus b upon 2a whole square plus 4ac minus b square, 4ac minus b square whole divided by 4a square. Yes or no? And now you can integrate using the method. This will be written as, this particular format can be written as integration dx upon x plus b by 2a whole square plus root d upon 2a whole square, and now it can be integrated as 1 upon x square plus a square format. If my d is not less than 0, then it will be integrated into the form of dx upon 1 dx upon x square minus a square. By substitution we have derived that particular also. Now look at here, this was the methodology, but I'll tell you how to solve into the format of using this particular case of integration. Take an example of this. I can be written as dx upon like 3x plus 2 dx whole divided by x square plus 3x plus 2. This is my question. Let us take an example. What I have to do? Just I have to take a step by mentioning this denominator as a differentiation, this as a differentiation of this particular denominator, and I mean then I can take let 3x plus 2 can be written into the differentiation format of a times d by dx of x square plus 3x plus 2. Is this clear to all? Plus b. And that same thing you are going to mention over here also. A times d by dx of x square plus 3x plus 2 plus b. Is this clear? Whole divided by x square plus 3x plus 2. I hope I am very much clear to all the students. Now one thing more. After taking the differentiation, the same process will be followed which I followed in the previous particular slide. What is that? 3x plus 2 can be mentioned as a into differentiation of this, that is 2x plus 3 only, and this one is nothing but p. Now after keeping this step, just I have to mention the comparison after multiplying this a into the bracket 2ax, and what I can write, I can mention like 3a plus b also. A into 3, 3a plus b, correct? Now comparing the coefficients and constant term, then this 2a can be written as, after comparing this coefficient, I can write 2a is equal to 3, then a will be equal to 3 by 2. Yes or no? Now 3a plus b I can write is equal to 2. This is the constant term into the left hand side, correct? Then a I can substitute as 3 by 2 and it will become 3 by 2 into 3 plus b is equal to 2. Now what will be b? B will be 2 minus 9 by 2, and I can mention it as b is equal to 2 to the 4, 4 minus 9 is coming out to be minus 5 by 2. I am getting a as 3 by 2, b as minus 5 by 2. And even people are so smart and intelligent, they are not going to utilize this method also. They keep going on with the manipulation and they used to simplify the integration. Instead of taking 3 into the common, multiplying 2 and into the numerator denominator, manipulating with the constant term b and all, and simplifying the answer. Yes or no? They don't use this particular method also. Just they utilize the manipulation and find out the answer. Now one thing, after utilizing this, if you are not in practice, you can take it as a methodology. If you are expert, you are calculating the things very fast, no need to go for this one. Just do one thing, what? Take 3 common. Now make it differential over here in the numerator. Then I need to multiply with the 2 over there. Into the numerator denominator, 3 by 2 it will become, and it will become 2x. Now see, a is coming out to be 3 by 2 over here also, and here also we are getting 3 by 2x over here and 3 by 2 here. After taking 3 common, multiplying with the 2 into the numerator denominator. Then when you will take 3 common, it will become 2 by 3, and when you are going to multiply 2, it will become 4 by 3, and you need what? 3. Then you are going to subtract and add 3. Just I am going to mention here, then I will erase it. Like if I am going to take 3 common, it will become, I am mentioning the second method instead of this. This will become x plus 2 by 3 and multiplying with the dx, and denominator will remain same, x square plus 3x plus 2 also. A mathematics student has to be very smart so that he can click number of methods which can let him solve the particular question into the speed. Then I is equal to written as, I am going to multiply with 2. Why I am going to do this? Just look at here. After doing this, when I am checking the differentiation of this, I am getting 2x plus 3, correct? So 2x I am getting, what I need only plus 3 and minus 3. Then I'll do what? I'll just add and subtract plus 3 and minus 3, and I am going to keep this dx element, x square plus 3x plus 2. Now see, 2x plus 3 differentiation format of this one, and 4 by 3 minus 3, 3 3 is 9, 9 minus 4 minus ka 5 by 5 by 3 I am getting, correct? Now one thing is what, just you have to see one thing, when you are getting minus 5 by 2 over here, then you will be having minus 5 by 2 when this will be multiplied into the numerator. Is this into the numerator when you will take separate both of them? Is this clear? Is this understood? And this is what I am mentioning over here. Just see, just a minute, dx. Now you can multiply this 3 by 2 inside. You will see 3 by 2 integration of 2x plus 3 into the first part, and into the second part, denominator will remain same. I have kept inverted comma over there of the same. Clear? And the second one is what? 4 by 3 minus 3 is what? Minus 9 by 5. 3 3 is a 9, 9 minus 4 is coming out to be 5, 5 by 3 it is becoming, yes or no? Then 3 by 2 I am going to multiply, then it will be plus 3 by 2 minus 9 by 3 whole divided by the same denominator. Now see one thing, this 3 is cancelled and minus 9 by 2 is there. After one thing more, after simplification it is becoming 5 only, because this is the 4 by 3 constant term clubbed with this minus 3, 3 3 is 9, minus 9 plus 4 is minus 5 by 3, and 3 is by 3, it is this 3 is cancelled, minus 5 by 2 is the answer. Done. Now come, it is not required when you are not in practice, you are beginner for that. Else what you will do, just we have to simplify. A is what? A is 3 by 2. Okay sir. And what is the differentiation of this? So 2x plus 3. Very good. Dx whole divided by x square plus 3x plus 2. Yes sir. What is B? Minus 5 by 2. Just keep it outside. Dx upon, just because this will also be multiplied with the element dx. Is this clear to all the students? Now one thing more, students. This is tx upon x square plus 3x plus 2, and we are going to simplify this step as 3 by 2 is outside, this is 2x plus 3 into dx, and this one is nothing but x square plus 3x plus 2, and this is written as minus 5 by 2 dx, and we are going to utilize the completing the square method over here. What is that? X square is written as x square. We are just multiplying 2 into the numerator denominator so that I can make into the format of x square plus a square or x square minus a square, correct? Then just I am multiplying 2, I am writing x, and the 2 which has to come into the denominator, I am mentioning it into the format of 3 by 2. Now this is a square plus 2a, this is b, then I have to add b square and we have to subtract as well. Then it will be plus 3 by 2 square minus 3 by 2 square plus 2. Is this clear? Now I will take what? Take it as d, t, y, whatever what you want to mention. X square, let x square plus 3x to be what you can say, t. Then simply differentiation will be 2x plus 3 will be equal to dt by dx, and 2x plus 3 into dx will become what? Dt. Yes or no? And in the second case, what you will mention over here, you have to just simplify. It will be written as x plus 3 by 2 whole square. This will be 9 by 4, 4 to 8, and this will be something minus 1 by 8. Am I right? Not minus 1 by 8, minus 1 by 4 type. Now we have to simplify this one. If we have to simplify this one, just take a copy, not blank one. Now simplify it. Now simplify this one, simplify this one, simplify this one. Just wait, just wait. Now what I can do, I'll take the step after this one, then this will become I is equal to, even we can remove this one. I is equal to 3 by 2 is outside. 2x plus 3 dx will become dt, and it will become dt upon t. And this is the famous integration we have done so many times. Minus 5 by 2, and this will be written as dx upon x plus 3 by 2 whole square, and this will be simplified as minus 9 by 4 plus 2 by 1. Yes or no? Now students, just take a step and simplify it again. We know 1 by t, integration of 1 by t will become log of modulus of t. Then it will be written as I is equal to 3 by 2 natural log of modulus t. Why I am putting t into the modulus? We don't know what is the t. It can be positive, it can be negative. Now minus 5 by 2 dx divided by x plus 3 by 2 square, and this one is written as 4 to 8, minus 9 plus 8 minus 1, minus 1 by 4 will be minus 1 by 2 square. Now this is the format, integration dx upon x square minus a square, and this is nothing but 1 by 2a log natural x minus a upon x plus a. I hope this is visible to all the students. I hope this is little bit sticky with over there, and but you can see the last lecture also. This is the formula. One wait, I'll mention this formula. Just wait. The formula of this one will be like this: dx upon x square minus a square will be written as natural log, but 1 by 2 is outside, natural log of modulus of x minus a upon x plus a plus integrating constant c. Yes or no? Now solve it. I will be written as 3 by 2. Resubstitute the value of t. What we have, you have assumed t as x square plus 3x plus 2. Mention it, x square plus 3x plus 2 modulus. Can it be negative? Yes, it can be. Like minus 1, minus 2 are the roots of this. The minus 1, minus 2 are the critical point of this. Between minus 1 and minus 2, this expression is negative. Got that? Between minus 1 and 2, excluding minus 1 and 2. Clear? Now, minus 5 by 2, this one will be written as 1 by 2a. A is what? A is what? 1 by 2. Log modulus x. What is x? X plus 3 by 2, sir. Minus a minus 1 by 2 whole divided by x plus 3 by 2 plus a plus 1 by 2 plus integrating constant c. Is it simple? Yes sir, it is simple now. Now remove all the things. From 2, 2 is cancelled. Yes or no? Now what else mention? Sorry. 3 by 2 natural log of x square plus 3x plus 2, and after that I can write minus 5 by 2 natural log of modulus of 3 by 2 minus 1 by 2 will be written as x plus 1, and these are nothing but factor of it. Whose factor? Factor of this. Yes or no? Into the question also it is mentioned. Plus c is the answer. This is the answer of the question. What I mentioned. And the method also. How you utilize differentiation of the denominator to solve the numerator. Yes or no? Now next one evaluation of simple integration of the type. Now we have to solve such kind of integrations. For that, I have already told you, just to do the solution of this particular situation, we have to utilize the concept of the same 1 upon ax square plus bx plus c, and I'll let you know what is that. After simplification, it will become like this. Just you have to take root a common, so it will be 1 by root a. Now this will be in the root, this will be like x plus b by 2a whole square minus b square upon 4a square plus c. Yes or no? This will be minus b square by 4a square, and this plus c will be the constant remaining over here. After simplification, the same thing will be this. Yes sir, c by a. Correct? Now see, after doing this, my integration will depend on two things. Is this negative? Is this positive? Now first thing, if it is positive, if d is greater than 0, what is d? D is b square minus 4ac. You can simplify like 1 by root a integration dx upon root over x plus b upon 2a whole square minus times b square minus 4ac. You can mention here b square minus 4ac as d also, so that you can simply simplify the answer. It will be root d by 2a whole square. Now this one is nothing but x square minus a square. If d is greater than 0, then you will still simplify it like, you can simplify this as, if d is greater than 0, simply listen this, if d is greater than 0, you have to simplify, use formula to simplify this one, dx upon root over x square minus a square. To simplify this one, if d is not greater than 0, it is less than 0. If it is less than 0, then what you have to do, first I will become nothing but 1 by root over a integration of dx upon root over x plus b by 2a whole square minus 4ac minus b square whole divided by 2a. This one. Now take it as whole square, and you will simplify it as, apply formula 1 by root a dx upon root over x plus b by 2a whole square plus root over 4ac minus b square upon 2a whole square. Likewise, you can simplify this one. And which formula you will apply? You will apply dx upon x square plus a square formula. Yes or no? I hope this is understood to you, how to solve such kind of situations when different segment can be applied. Either d can be positive or negative, both it can be, and according to that we have to simplify the particular integration. Is it clear? Now take an example for this. We will take an example for this to understand how you can utilize I is equal to dx divided by root over x square plus 5x plus 6. Take this an example. Yes or no? No need to take, okay, you want to take example like so that, is there any scope to take common? Then take an example of this, 2x square minus x minus 3. Yes or no? This is a very simple example. Even you can see the middle term splitting, through the middle term splitting you can see this factorizable. Yes or no? But no need to factorize till now. we are just going to integrate this particular situation using one of the method, 1 upon root over x square minus a square, or 1 upon root over x square plus a square. Whatever the method is, that will be implemented. Now see, in this particular situation, I am going to take root 2 common. Now 1 by root 2 is common. Yes, sir. Dx upon what we can write. Root 2 is common, sir. After taking 2 as common out of the root, it will become x square minus x by 2 minus 3 by 2. Any doubt? I am going to make it perfect square. After making it perfect square, it will be 1 by root 2 dx divided by whole square. I am going to make by the trick I have taught you into the quadratic equation chapter in the 11th class. What was that? Just take x square as x, take the coefficient of half of the x, that is minus 1 by 2, keep it half, it will be 1 by 4. Yes or no? Whole square. Now it is like b by 2a. You have to go add a square of this and you have to subtract square of this. Then this will be minus 1 by 4 and plus will be involved with this one, minus 3 by 2. Yes or no? After solving this one, I can write I will be written as 1 by root 2 dx over x minus 1 by 4 whole square (1 by 16 and minus 3 by 2). I am going to take LCM. What is that? This will be 16, this will be 2, then LCM will be 16. Yes or no? And I am taking minus common out of both. Yes or no? Now this will be 1 plus 2 8 is 16, 8 3 is 24. This will be 24, and this will be simplified as I is equal to 1 by root 2 integration over of dx upon square root of x minus 1 by 4 whole square, and this will be written as 5 by 4 whole square minus 5 by 4 whole square. Yes or no? Now think which type of integration it become. You have studied it. What is that? This is, sir, nothing but integration of dx upon root over x square minus a square, which is nothing but natural log of modulus of x plus root over x square minus a square plus integrating constant, modulus close. Yes or no? We have done it or not? Just apply it. After applying this, you can see the answer will be 1 by root 2 log of natural log of x. What is x? X minus 1 by 4. Yes or no? And this is nothing but x square minus a square. Then this quantity will be written as it is. Yes or no? What is this? Root over x square minus x square. That is nothing but the actual integrating term. That is the root over x square minus a square. This one. Then I have to write this one into the. What is x over here? This one, x minus 1 by 4 plus root over this particular thing, that is x minus 1 by 4 whole square, x minus 1 by 4 whole square minus a square, that is 5 by 4. Is this clear? Modulus close plus integrating constant c. Now you can see we have done it in the previous lecture also, where I have derived this particular situation for you guys. Yes or no? So just go through that lecture, derivations, what I taught yesterday, and just get the feeling, yes, we know the formulas, how to derive them. Now come to the today fundamental we are describing. This one, this is the solution of the question. This is the final solution of this particular situation. Now one thing, this is what answer of this. Okay, where is that? This one only. Okay, so this is the solution of this particular situation, and this one is the answer. Now come to the next, evaluation of simple integration of the type. Now how you will do this? Again the same methodology will be utilized. What is that? Just describe px plus q into the format of a times d by dx and simplify that. Yes or no? I'll give you the example. Through that we will solve it. Otherwise the derivation will remain same what we utilized in the previous one. Now take the example. Example we can take. If I have to take the example, I can mention integration of x minus 1 dx whole divided by root over x square plus x plus 1. Is this? Now you are going to apply this particular step on this particular question. Since we are having square root of x square plus x plus 1, x square plus x plus 1's square root over is given over there. Now we have to link this x minus 1 into the differential format of x square plus x plus 1. Now we have to take this step, this one. I am going to mention x minus 1, let x minus 1 is equal to a times differentiation of x square plus x plus 1 plus b. Now differentiate it. X minus 1 will be what? 2x a times 2x plus 1 plus b. Now multiplying this a into the bracket, we are getting 2ax plus a plus b. Now comparing both the side, what we are getting? 2ax as x, then 2a will be 1, the coefficient of x. Yes or no? What is the coefficient of x? Coefficient of x is 1. Then 2a will be 1 and a will be 1 by 2. From here what we are getting? A is equal to 1 by 2. Now a plus b is what? A plus b is nothing but minus 1. Your a is 1 by 2, just put there. It will be minus 1 by 2 coming out to be minus 3 by 2. Now just substitute it here, so that what you can say, my px plus q, yani my x minus 1 will be nothing but a 1 by 2 of x square 1 by 2 of d by dx of x square plus x plus 1 plus b is nothing but minus 3 by 2. This one. Just now differentiate 2x plus 1 ka half. It will be x plus 1 by 2, x plus 1 by 2 minus 3 by 2 is resulting in x minus 1. Yes or no? Now just put this entire expression into the given question. I have copied it. Now I am going to erase it. Just substitute this one over here. What you can see now, I am just substituting the values, that is half d by dx of, directly we can differentiate, that is nothing but 2x plus 1. What is the differentiation of x square plus x plus 1? That is nothing but 2x plus 1. After that plus b is what? Minus 3 by 2. And keep it into the bracket, dx divided by square root over x square plus x plus 1. Is it clear? Is this understood to all? Now listen students, this one is written as half is taken out of the integration, 2x plus 1 into dx is the element. I am going to substitute into the differential format of this particular square root, that is x square plus x plus 1. Now minus 3 by 2 will be the second integration part, that is minus 3 by 2 integration of dx by root over x square plus x plus 1. Yes or no? Is this clear? Any problem? Now simplify it. What I can do? half. Now let it, take it as let x square plus x plus 1 is equal to 2t into this particular integration. Not for that, after differentiating I am getting 2x plus 1 into dx is equal to dt. Is this understood? Any doubt? Now 2x plus 1 dx is equal to dt I am going to substitute here, and this will become I is equal to 1 by 2 of x square plus x plus 1 will become root over t, and this will be dt. And after that minus 3 by 2 dx upon root over, you will write like x plus 1 by 2 whole square. Make it perfect square, make it perfect square into the previous cases like. Then it will be x square plus x plus 1 by 4 plus 1 by 4. Then out of 1 by 4, out of 1 I am taking 1 by 4, then remaining will be 3 by 4, and this will be written as root 3 by 2 whole square. Yes or no? I hope this is understood to all the students. Then I will be written as 1 by 2. Integration of root t will be what? It will be written as t to the power minus 1 by 2 plus 1 minus 1 by 2 plus 1, and integration is over for this particular step. Now minus 3 by 2 it will be, and I will be integrating like, how you can integrate like this? This is nothing but dx upon root over x square plus a square. Then the final integration will be directly can be written as natural log of modulus of x. X is what? X plus half plus root over x square plus a square, यानी कि x plus half square plus root 3 by 2 square. Is this clear? This is your modulus close plus c, and this is the answer. I hope this is understood to all the students, how we can integrate such kind of questions. Yes or no? Now next is what? Integration by parts. To integrate few particular situations where the integration directly not applicable, like if you have to integrate log of x, natural log of x, then I cannot integrate it directly. For that, the thing comes up of the concept of integration by parts, and how we can do it. Questions like this cannot be solved directly. Previous taught methods like substitution, antiderivative and all. Substitution, antiderivative and all. From those methods you cannot integrate such kind of expressions like log x, or we can say integration of like tan inverse x, or you can say e to the power x sin x. If you have to integrate such kind of integrations, you cannot perform directly using substitution and antiderivative method. For those, we have to take a new rule, new concept, which is called as integration by parts. What is that? I taught you integration, not integration, in the differentiation product rule over there. What was that? If you have to differentiate, like, take an example. First, I'll let you know what is the integration by parts. The result is nothing but this one. If you have to integrate such functions, those cannot be integrated directly into the general method of substitution and antiderivative. For that, you have to consider one of them as a differentiable and one is integrable. The integrable will be integrated, and the differentiable is going to be differentiated. Yes or no? Means let us take an example. This is first and this is second. How the first and second is decided which will be integrable and which will be differentiable? By the priority of islet. There is a rule of islet. What is the rule of islet? I'll let you know. Then I'll derive how we are getting this method. I stands for inverse. L stands for log. L stands for log. A stands for algebraic. T stands for trigonometric. And E stands for exponential. Is it clear? These are the functions: inverse functions, logarithmic functions, algebraic functions, trigonometric functions, exponential functions. This is the priority which is differentiable first. Yes or no? Order of differentiation. The term will be taken as differentiation term. Is it clear? Now, what you have to do? According to this order, you will decide which term, which particular function will be taken as the differentiation term and which particular function taken as integration term. Correct? But likewise, to what you are going to integrate and to what you are going to differentiate. First means you are going to differentiate it. Gx, this is taken as second part of the function, is considered as integration part. Then it will be written as fx will be taken out, integration will be done of gx minus differentiation of fx will be done. After differentiation, it will be multiplied with the integration of gx and the whole term after the integration will be integrated again. Is this clear? Is this understood? This is the method of integration by parts. Now I am going to link it with the product rule in the differentiation. Product rule in the differentiation will be written as like this. You have just studied the product rule in the differentiation is like, it can be written like this: fx gx. I have to differentiate these two particular functions into the x and I am going to apply differentiation over there. Then it will be written as f dash x gx plus fx g dash x. Yes or no? Now understand, if I am writing like this, if I am going to implement integration over there, then how it will be written as? Just look at, if I am going to apply the integration, if I am going to apply the integration over here, then it will be written as like this: d by dx of fx gx is equal to f dash x gx plus fx g dash x. Yes or no? Dx I can write likewise this. Now understand, this is totally different example taken previously in the slide. If I have chosen what, my fx as differentiating part and gx as integrating part, then I am taking it as first and it as second. Means the integration will be done with this part and differentiation will be done with this part. Then this can be written as fx g dash x dx, taken it as first, taken it as second, and it will be written as differential element, and this differential element will be cancelled, and the final result will be written like this: fx gx, fx gx, and gx is what? Integrating term of integrand of the particular g dash x, correct? So what I can write, d by dx of g dash x likewise this. How I can write? I can write likewise this: integration of d by dx of gx of dx, likewise. Is this clear now? Now the thing, this is taken into the right side and it is written into the left by rearranging, and this one is written likewise this. This fx is written over here, dx is cancelled, integration was written. First I will mention like this, again I can let you know how to do it. Fx dx is correct, okay. Now this is going to transpose into the left side and we are going to rearrange it. Now it can be mentioned as minus f dash x gx into dx. Is this clear? This is written in transposing into the left side, and after rearrangement this is the answer, and this one is written here. Now listen students, this product rule we are going to generate like fx g dash x, we are taking it as first, this is as to be second, and I am just transforming this into the integration differential form. How? Fx is written outside, we are mentioning integration or differentiation of gx g dash x dx. You can write likewise this also, or into the format of d by dx also, minus d by dx of fx integration of g dash x dx, and whole integration will be done after this one. This is from product rule, this is the one way, and one more way you can take it from here also. By keeping the thing in the mind, just take this one as an example and just differentiate it by using the product rule, and after product rule just transpose and get the answer. Is this clear? I hope this is clear to all the students how to do such kind of integration by parts. And the example of integration by parts I am going to mention here, like if I am to integrate log of x, then I'll take what? I'll take 1 into log of x dx, and I'll mention 1 as integrating and ln x is differentiating term. Ln x, which is the highest priority term, and 1 is taken as constant algebraic expression, correct? I am going to integrate this, I am going to differentiate this. Now apply Eilert rule, integration by parts, and I can mention 1 ln x outside, integration of 1 minus integration of differentiation of ln x, integration of 1 dx, whole integration of dx, correct? Now just apply Eilert and utilize the integration by parts property, you can find out the answer. 1 means integration of 1 means x, differentiation is of 1 by x, this is we are getting x, and this is the element dx, x is x cancelled, this is we are getting x into ln x minus 1 dx becoming x, correct? Now see, integration of ln x after applying integration by parts is this one, and you cannot think of this by antiderivative method, means considering assuming the particular function whose differentiation is this one, not possible. That is why the integration by parts concept is come out, yes or no? For today, this is done. In the next lecture, we will come with the concept of integration by partial fraction, and there will be few questions to let you know, to clarify your concepts, to strengthen your concepts. Thank you so much. Thank you.